Blackwell soccer this semester. Thankfully, there will be more in the spring, but this is it for the fall. Today we have Dr. Melissa Rhoten, who comes to us as chair of the chemistry and physics department. Dr. Rhoten got her PhD, I believe, from ECU. And she has, for the past year and a half or so, been doing this Pogle form of teaching introductory chemistry for at least some of the introductory chemistry classes. It's an inquiry-based learning technique that she'll tell us about, and because you did it last year, you have results.
I do.
So if you would please, welcome Dr. Melissa Rhoten from Chemistry.
Thank you very much. I'm happy to be here to talk to you about this thing called Pogle, and I will hope to explain what that acronym means in just a few minutes, but being true to form, since you have food in your mouth, I want you to discuss something with your neighbor, please, or with your neighbors. So you're in nice tables of 3, so if you will take a couple of seconds and talk about this idea here. You're a member of the employment committee for a startup biotechnology company, and you're planning to double your number of employees over the next year. This was pre-recession. So could you talk about 3 characteristics or skills that your committee would like to use or would like to see in potential applicants? And just jot a few of them down. We're not going to take very long to do this, but just a couple seconds.
Okay, so what kind of skills did you guys come up with? What do you want to see in your applicants' applications? Anyone want to share some?
Jake wants to.
Jake?
We need to have a woman in that position.
A woman, okay. What else?
We touch communication skills,
Competency and
competency in the field,
Okay.
creativity, and self-motivation.
Okay, anything else? So anything that's different from those? Publications, okay. Anything else? Okay, sense of humor, aptitude.
No grammar mistakes in the cover letter or resume.
Okay, that's good.
Creative personality that works with whatever your team is.
Okay. So when I thought about this, I thought of some of these things here. We want people that are quick learners, critical thinkers, creative, problem solvers, good communicators. You guys pointed that out. Team players, self-motivation, and down here on the list is this idea of some knowledge base. And what I want to point out is that this is only one component out of this nice list. So I've been here for a long while teaching freshman chemistry for science majors and have tried a lot of things to get students to be knowledgeable in that subject area and hopefully obtain some of these other skills that are on this list. But teaching in a traditional format doesn't lend itself nicely to some of these, to students obtaining some of these skills. So what is Pogle then? So Pogle is an acronym that stands for Process-Oriented Guided Inquiry Learning. And it's a technique that can be used in the classroom or the laboratory, and it seeks to teach content because we're all interested in students learning content, but at the same time, we want to also convey to them some key process skills, and we want to do all of this within the confines of a collaborative team. So research shows that students who work collaboratively learn more, they understand more, they remember more, and they acquire skills essential for the workplace. So in the Pogle classroom, students work in small groups on specially designed activities that are intended to teach them the content that they need and to give them some of these targeted process skills. And those things include things like information processing, critical thinking, problem solving, teamwork, communication, management, self-assessment. These are all things that Pogle activities are designed to do. So if we look at traditional pedagogy, probably the pedagogy that all of us experienced, and maybe we are using still, it says that teaching occurs by telling. I'm the person in the front of the room, the talking head. You are the people sitting there writing feverishly things down that I say, and maybe not getting everything that I say accurately. It also says that knowledge is a collection of facts, and that in order to convince me, the talking head, that you have learned something, you have to recall all of those facts and regurgitate them to me somehow on a test. And I already talked to Stephanie. She's our psychologist in the room, and this is a little bit of cognitive psychology. I am not a psychologist, but when reading the chem ed literature, especially when looking at this idea of Pogle, we have to think about how people learn. So specifically, if we think about the process of learning, one thing that's really interesting is that we all have this unique perception filter. Okay, and that's where we have our interests, our prejudices, our beliefs, and that filter controls how we handle new information, how we receive external stimuli, and how we store information. And it allows us to select the things that we're interested in, it allows us to make sense of those things, and to determine what's important to us. Also within this model, we have this little area here that's called the working space, and it is limited in size, and it's a shared space that holds information temporarily and allows us to process it. So what we see is that we receive information through the perception filter, we hold that information, and we process it in order to get it into long-term memory. If it requires a lot of processing time, then we can't receive a lot more information into that little area. If, however, we don't have a lot of processing to do, we can take in a lot of information. So if we form linkages between new information and the current knowledge that we have in our long-term memory, then we say that understanding occurs. If the linkages are faulty, that can give rise to alternative frameworks or misunderstandings, misconceptions. And if there are no linkages made, then we have no understanding, and that means that we either reject that information or we turn ourselves over to rote memorization of things. And we all know that when you memorize something, you have a tendency not to remember it, 3 minutes after you leave the test. Do the information dump. So a new approach, or a new sort of pedagogy, says that knowledge results through active participation in its construction. So if you think about this working space, if we are processing and receiving information and we are constantly doing something with that, that's going to help us form connections that are going to lead to storage of that in our long-term memory and learning. And in this new approach, students teach each other and they teach the instructor, actually, by revealing their understanding of the subject. And teachers that are using this approach learn by the process by steadily accumulating a body of knowledge about the practice of teaching. So you've all heard the old saying that what better way to learn something than to teach it? And I think that that's really true. So the guided inquiry approach. Students work in groups typically of 3 or 4. I think 3 is a better size than 4. The activities that we use model the learning cycle, and that's where there's some exploration phase, there's some concept invention, and then you apply these concepts to solve problems. The students are actively constructing their own knowledge. So I'm not standing up here telling them something. They are working together with one another, trying to construct this knowledge. The students teach, discuss, and learn from each other, and an instructor is just a facilitator of this process. So I wanted to give you a taste of what a Pogle classroom is like. Because lots of you are probably saying, well, what do these activities look like, and what do you actually do? Are you teaching? What are you doing? So I want you to put yourselves into teams of 3, and you need to assign yourself one of these roles. This is exactly what I do in my class, although at the start of the semester, I assign the teams to start out with. And I allow them to change as the semester goes along, but I typically like to keep the same teams at least until the first test, so that there's some continuity. But the roles change on a daily basis. So one of the ways that you're going to decide who's the manager, the oldest person in your team is going to be the manager. So that gives the students a little bit of impetus to learn something about one another, because they don't know each other typically in this class, because the majority of the students in this class are freshmen. And they're first-time freshmen, and so they typically don't know one another. So, manager, your job is to participate, so you don't sit there like a bump on a log, you participate, But it's your job to keep the team on task. I don't want to hear about the football game yesterday. We don't want to talk about what we're doing tomorrow. Or if you're going to a party, we don't want to hear any of that. We want to talk about the activity itself. Okay, so it's your job to keep the team on task, and you need to distribute the work or the responsibilities if there are some to distribute. And you have to make sure that everybody participates and that everybody understands. So if 2 of the 3 of you get question number 5 and 1 of you doesn't, don't say, oh, we'll come back to it. No, don't do that. It's your job to make sure that everybody understands. The recorder, you're also going to participate. You are going to prepare a report at the end of this activity. And the reporter, you're also participating, but you are the only one that can talk to me. Okay? Because with trying to manage a group of a classroom full of groups, if everybody on a team wants to talk to me and has a question, that would be very difficult for me. So we have to have somebody who collects the thoughts of the group. If you have a question about something, you raise your hand. You're the one that gets to talk to me. Anybody have a question about these roles?
So if we have 4 in our group, we can have 2 recorders or?
Yeah, 2 recorders would be fine. If you have 4 in your group, yes, you can do that.
Do you assign the roles? Or?
I assign them initially. Okay? In the initial class meeting for that particular day, I assign them initially, but the next day that we meet, I will say some question. I'll say, the oldest person in your group is going to be the manager, and they all ha 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 ha. And then the recorder is going to be the person who drives the oldest car, and they all laugh, and then that only leaves 1 person, right? So they know what the roles are, okay? All right, so go ahead and get yourselves into your groups, and I will hand out your activities. If you're in a group of 2, I would encourage you to encourage someone to sit with you. You don't know how old you are. Are you the manager?
If I must. I really abhor group work. It is nothing personal.
You don't want to be in a team?
I hate being in a team.
I'm sorry, you have to be. It's a part of it. It's a part of it. You don't get an accurate picture of what this is like if you're not in a team.
I'm only doing this because Jeff asked me. Otherwise, I would sit.
It's true, and they still have to. Okay, I could have missed some folks, I think. No, it's coming down the road.
Oh, it's coming down.
I missed you, right? All right, so we know who the manager is. The reporter is going to be the person who lives the furthest away from Farmville. Okay? Everybody get that? The person that lives the furthest distance from Farmville is the reporter. Okay, so let me just give you a little bit of instruction here. Okay, this is one of the issues, keeping people quiet for just a second. So let me give you a little bit of instruction. So you may feel a bit scared about this because you don't do chemistry, and that's the way the students feel, actually. They're nervous about this. So I would encourage you to read the information that's on the front. It's got important stuff there. And on the next page, you'll notice there's a model. Okay, you're going to be referring to the model and to the information to complete this task. Okay? So what would I like for you to do? I would like for you, in the next 10 minutes, to complete critical thinking questions 1 through 11. Don't do number 12, just do 1 through 11. Okay? If you have questions as a group, you need to have your reporter raise your hand, and I'll come and help you out. But I'll be circulating to make sure that you're all on the right track and that you're not going awry. Okay? So I expect that this is going to be a noisy time. Okay? Okay, so can everybody just give me your attention for a second? So the reporters in each group,
If you can tell me the answer that you got for question number 4. What information is provided by the atomic number Z, which is the subscript in the atomic symbol? So what do you get from Z? Somebody, a reporter, raise your hand. Doesn't matter. I'm not going to do it. Reporter. Okay.
Right, so we have the number of protons and electrons.
Okay, so the number of protons and electrons, do you mean the sum of the number of protons and electrons?
No.
So just, it's the number of protons and it's the number of electrons. Anything else that's important about that?
We haven't really gotten there, but it's only the number of protons if it's not an ion.
Okay, so
If the number of
it's
electrons
only
are
the number of protons.
I mean, it's
if
always the number of protons.
If it's the number of protons.
Don't
Okay?
remember of electrons.
All right. How many reporters from all the groups, you have to vote, okay? Do you think that Z tells you the number of protons? How many of you think that Z tells you something else? Okay, so tell me what else you think it tells you.
I'm not saying that.
Who else? You said that
I'm
too.
with Liz on this one.
Okay, you're with Liz. So you think that, do you agree that it tells you the number of protons?
No.
You don't think it does?
I don't think so.
You don't think so. Okay, let's look at it more carefully, okay? So we have, our atomic symbol is X, right? So the symbol for the element is X. A is the mass number. Z is the atomic number, okay? So if you look at all of the examples in sodium, the atomic number for all of those is 11. If you look at the information on the other side for the pictures, notice that all of those say that you have 11 protons, 11 protons, 11 protons, right? Yes? For all of those. Okay? So is it just coincidence that all of those things have 11 protons and that Z number is 11?
Oh, it's a conspiracy.
It is a conspiracy, exactly. So no, it is not a coincidence. So Z is going to tell you the number of protons in a particular atom, okay? But perhaps it does give you a little bit more information, but you have to have some stipulations to get that other information. It will also tell you the number of electrons that exist if the atom is neutral, okay? All right, so if the atom carries no charge, it should have the same number of protons as it has electrons, because what kind of charge does a proton have? Positive. What kind of charge does an electron have? Negative. They're equal and opposite in magnitude, okay? All right, thank you. Continue on. I just wanted to make sure we're on track here. Okay, you need to move a little bit quicker. Which particle is closest to the mass? Okay. So there's a chart up here, right? So you need to pay attention to this chart, and there's some information that's right here that's going to help you with that question too. So for this particular, model, the only thing that we're looking at for charges is positive. Yeah. Negatives are possible.
The mass is over the whole instead of round. I don't feel like
Shower episode.
Okay, stay on.
I think that we need to go ahead and move on so that I can finish the rest of my talk. But I wanted to give you this taste of what it's like to be in the Pogle classroom, and so that you can see what I'm doing, right? So I hope, maybe some of you started out being, oh my gosh, I can't do this, this is chemistry, but can you see at least how you are taking the model and using information, so you're using information processing, you're doing some critical thinking, you're managing yourselves in a team. You will in a little bit have an opportunity to reflect on your team's learning. So you're learning content knowledge, but you're doing so much more than that, right? You are practicing these process skills that are so very important when you get out in the real world, okay? So that's one of the great things about Pogle, is that you get to actually do those things every single day in class. So I hope that you aren't still scared of chemistry. Okay? All right, so just to continue with what you might see in the classroom activity, so I would have, as we had gone along in the activity and gotten finished with it, I would have asked everybody to stop working, and I would ask you to together ponder this question and come up with the answer to this question. And I have, we don't have clickers in the classroom that I teach in, so I have a very crude system of colored cards that have A, B, C, and D on them, and I ask the class to hold up their cards and tell me what the answer is, and so they're colored because it's easy for me to sweep the room and see that everybody's got the right answer or not. So I would have asked them to do that, and then I also would have asked at another period of time to come together and to talk about this particular question, and then I would have asked some of the reporters to sort of report out to me and tell me their answers. So that gives me a way to sort of spot check to see if the groups are doing what they need to be doing. Okay? The other thing that's always a part of my classroom PowerPoint is you need to complete your recorder's report, and I'll show you what that looks like, and then if there's any homework that needs to be done. So for this particular activity, I sent them home to do exercises 1 and 2, which is on the back of that page, and they had to turn in a group answer to these questions at the start of class. So they got, for their homework, they got a group grade for that particular homework assignment. So, and I also told them that in order to get credit, you have to have participated in doing this, and so at the start of the semester, they think that that's true, right? I mean, they are going to work together, and they sort of learn as they go through the semester, and this is not a good thing, that they can influence their friends to say, oh, I couldn't be there, but just write my name down. So I've had some people, I've had to deal with that a little bit when I do group work, but we've all had to deal with that, I think, when we do group activities. The recorder's report looks like this. So I want to know who the team members are, and then I want them to reflect on what they did in that particular session. What questions does the team still have about the material that's covered today? I put that on there because the next class period, I start the class period with a 5-minute mini lecture that focuses on this particular question. So if everybody just did not get the concept of what's an isotope, I would start my mini lecture there. And I only let it go just for a few minutes, and then we start another activity. I also want to know, did everyone in the team understand the material? If so, explain how your team is sure that everyone understood. If not, what does your team need to do to make sure that everyone understands the material by the next session? So this is the idea of letting them practice this whole idea of assessment. Okay? And we know that we don't necessarily like that word, assessment. Okay, so let's look at what we found in our particular study. We've used Pogle in Chemistry 111 and 112, and that's a 4-credit lecture lab course, 3 hours a week of lecture and 1 2-hour lab period per week, and it's required of all science majors. It is the introductory course for everybody, biology majors, physics majors, chemistry majors. In the fall of 2009, we had 6 sections of Chemistry 111 taught by 3 separate faculty. So each of us had 2 sections of Chemistry 111. And then in the spring, we had a Chemistry 112. We only had 5 sections because we always have some nutrition. And that was taught also by 3 separate faculty. 2 of us had 2 sections and 1 of us had 1 section of Chemistry 112. So here's a breakdown of what the students look like in these sections. So I'm going to call the sections the traditional lecture, that's the talking head, right? The Pogle model, what you just saw. And then we have what we call the hybrid Pogle model, and I'll talk to you about what the hybrid is in just a second. So basically the classes were equally distributed, about 50 students in there. And the students didn't know when they signed up for classes that there was going to be any difference in these particular classes. So they self-selected themselves into these classes. The chemistry majors somehow ended up in the Pogle section, and I think that's because there was a time conflict with something else that they had to take. And so we did some statistics, and we found out that the results that we obtained in this study were not biased because the chemistry majors were all in that section. I hoped that they would be, but it didn't bias the study at all. So you can see that the large majority of students that are in this particular class are biology majors. That's the biggest of the science majors that we have. So we had some commonalities. We used the same textbook, and we had the companion Pogle workbook. We did the same laboratory exercises. The labs were not Pogle, although you can use Pogle in lab. We chose not to. We wanted to focus on using Pogle in the lecture. We gave the same test review problems. We gave the same in-class tests. We gave the same standardized final exam that's put out by the American Chemical Society that's specific to first semester general chemistry. And then we used something that's called a concept inventory test, and we didn't find this until the semester had started, so we didn't get to do the pre and post, so we just gave it in the post fashion. This semester we gave it pre, and we will give it post again. The topics, we don't need to belabor this, but these are just very common standard topics that you see in a first semester general chemistry class. So you just got to do the structure of the atoms, just a little taste of that in your exercise. So the format of the lecture-based sections was, again, teaching by telling. Keith Ryder taught these 2 sections. And typically, I mean, he's a chalk talk kind of guy or a whiteboard kind of guy. He works out example problems. There's no group work, and he gives homework online using Blackboard. So it's maybe something that you would think about that's typical. The format of the Pogle sections, I gave daily quizzes because one of the things that I wanted the students to do, if they didn't finish a Pogle activity, they were expected to go home and finish it for homework. And so I needed some way to keep them in check for that. And so the best way for me to do that was to give them a daily quiz. Basically maybe 1 question, 2 questions, 5 minutes at the start of class, no more than that because I didn't have that much time. So we did our workshop session. So what you just did today, that's considered a workshop session. We had team reporting, mini lectures, either pre or post workshop time. We have wrap up and report writing. And I didn't give online homework last year. I used the daily quizzes instead. Okay, so the hybrid Pogle section, this was taught by Sarah Porter, and she hadn't 100% bought into the whole Pogle idea, but she liked what it had to offer. So she decided that she was going to be the talking head for 2 lecture periods per week, and then she would use the Pogle activities 1 day per week to supplement her lecture instruction. So and I've gone to several Pogle workshops and conferences, and there's a variety of ways that you can implement Pogle, and this is one of them. Not everybody jumps full force into just doing Pogle and not having lecture anymore. So she also used online homework assignments through Blackboard, and her assignments were very similar to Keith's assignments. So here are some of our results here. And you have to realize that in freshman chemistry, the spread on a test is enormous, okay? So test one, you might, green is lecture only, red's Pogle, yellow is hybrid Pogle. So test one looks like, wow, that didn't work out, did it? So the hybrid Pogle students did better than the Pogle students who did better than the lecture only students, and we sort of attributed this to the fact that everything that was on test one, all of the students had chemistry before they got here, all of that stuff was review for them, and so maybe that sort of overshadowed this Pogle effect. Bill?
Is there a problem with the charter to actually get, your third quartile starting at 100, fourth quartile starting at 100 on the hybrid course for test one?
There was some extra credit that they could have gotten. So when you get to test two, we really can see that there looks like there's a difference between how the lecture people are performing and how the Pogle people are performing. The same thing is true for test three, and the same thing is true for overall test performance. So we did some t-tests, and we found out that there is a significant difference between Pogle versus lecture for test number two. Significant differences for Pogle versus lecture and Pogle versus hybrid for test three. And there's a significant difference between Pogle versus lecture and the overall test performance. So, based just on one semester's worth of data, there looks like that this might be something that's useful to do for general chemistry. So we also gave them the same American Chemical Society final exam, and these numbers that are here are the percentiles that they on average scored. And I know that 28 looks a lot different than 45, but to score in the 28th percentile, to get to the 45th, you only had to get 2 questions more correct. So there really isn't that significant of a difference between how they performed on the ACS test, which is a little bit disconcerting because that means that they're not really putting this information into their long-term memory maybe. Maybe it works in the short term, but it's not working so well in the long term. And the same thing is true for the concept inventory test. We didn't see any significant differences between the 3 types. Now, let's see, what did the students think? So, they thought that I did not present things very well at all. And I can see where they would say that because I don't really present in this format, right? I mean, they're learning, they're inventing their own knowledge, basically. So I was upset by that at first, and then I sort of stepped back and thought about it. And I was like, well, that's true. I didn't, I'm not really presenting like they're used to. So some other things that I think it's really interesting that the hybrid students feel really, really good about themselves and about Sarah and their experience. But this is really bad for what I'm used to, let's just say, in terms of student evaluation. So I think the students typically don't like this. But I think if we continue to do it and it becomes this is just what we do, they'll get used to it and then this will go away. And it actually did go away in the second semester. My evaluations were back up because the students that had me first semester stayed with me second semester, and they really enjoyed their experience that they had with Pogle. I think it's interesting what the students had to say. We didn't have too much discrepancy here. I think they all were expected to learn difficult material. They all thought that. And it's interesting that Keith and I, the lecture only and the Pogle, they felt pretty much the same on all of these things. So the Pogle people didn't think they learned very much. But they spent a good amount of time outside of class, but they still thought that their grade was okay. So I don't put too much stock in this, but I do, sort of take away from it that the students are a little bit reluctant to this because it's different than what they might get in other classes and what they expect.
I don't think it's just a matter of different. We were just talking about this. I think, because I've been in some classes that used alternative pedagogy, like feminist pedagogy in the classroom. And when you actually talk to students, part of the problem is a perception of what you're supposed to be getting for your dollar at college, right? And the idea that you would pay tuition to come sit in a room and learn it on your own, I think students really don't appreciate that, because that's not what they think they're paying to get. So you would have to be able to make them understand that you're actually instructing in that kind of context, because I mean, I'm guessing that that's what's coming across here. And the hybrid model gives a little bit of both, right?
It does.
So you get the interactive works type stuff, but also the perception that the teacher is teaching. And I mean, that's not any kind of judgment. I just think that's the conception of what you think you're supposed to be getting when you're here. And if you're not, then you feel like, you know, that, oh sure, you know, you just sat up there in front of the classroom and we worked it out for ourselves kind of thing.
Could it also be that in groups, even though the manager is in charge and getting things done, the manager is neither equipped nor trained to kind of keep all the team members at the same pace? What if someone has real difficulty with the material? Whereas if it was instructor-led, I think you would be able to focus on that person, tease out some of the kinds of difficulties. Whereas a manager in a group may not be able to do that, equipped to do that. Would that be also some reason as to why students may not be all that comfortable in this kind of thing?
I think that's a valid point. I would say that I had 48 students in this class last fall. I had 2 senior chemistry majors that helped me facilitate. So there were 3 of us walking around, and we made sure that we went, you know, we don't just sit at the front of the room and do nothing. We were working the benches is what we call it, right? So you go and you stop and listen to what groups are talking about and what they're saying, and to make sure that they're not going down some path that's going to create these faulty linkages. So I think that that's a valid point, but I hope that, you know, that with good facilitation that you can get away with from that. Joanna, I think.
Yeah, it's interesting because we were talking about alternative teaching strategies in my freshman seminar last week, so I was very interested to hear this. Did you talk to the students up front?
I didn't.
About how this course would be taught differently and why it would be taught differently?
Yeah, okay. Yeah, so once, you know, the first day of class, I have a PowerPoint that I start with, and I talk to them about what the research says, and I show them, you know, some data from other institutions that use Pogle, and sort of give them the why this is going to be a good thing. I still think, though, that, you know, they're 18 and they paid their tuition to come and sit, and, you know, they want you to talk to them, and they want to take notes or not take notes and fall asleep, whatever they want to do. I think it's reluctance to have to keep their brain engaged the whole time that they're there. Chuck.
So it's very similar point, I think. Many of the things you're getting out of this course are not really specific to chemistry, and they don't show up on an ACS test, for example. I mean, the collaborative skills. Right. And they may not, at this point, understand the value of that.
Exactly. Don.
One of the variables you really haven't talked about here, you had 3 different instructors teaching 3 different ways. If we had one instructor teaching 3 different ways, I can see that, but every instructor, it may be the instructor rather than the method that is being reflected
That's
here.
true. So the best way to actually get at this would be to have me teach 6 sections and the teacher.
I realize that, but I mean, in terms of data analysis, that really is the way to go.
You're exactly correct. And we've talked about that. And the Pogle offices that I've been to, we definitely have talked about that. Jeff?
Some of the reluctance you run into may just be the newness of it, as you said. Yeah. When we first introduced Longwood Seminar here, the first couple of classes really resented having to take it because they had upperclassmen saying, we didn't have to take that. Why do you have to waste your time doing that? But once we got to the point where everyone at Longwood had gone through Longwood Seminar, and we were taking our 4th class in, there was no longer a class out there to tell them that, we didn't have to take that back in the old days. And then strangely enough, the evaluations we did at the end of the semester started coming out much better.
Yeah, I think that this fall class, I mean, there's a lot less of that now. Last fall's class with me, they seemed very reluctant to this methodology, but this class, this particular class that I have now, they do not seem as reluctant. So it'll be interesting to see if there are some changes in the evaluations that we get.
Do you think if you also use this at a higher skill level, that those students might see the advantages of the collaborative and
yeah, so Sarah Porter actually has written some of her own Pogle activities, which is a difficult thing to do for an advanced level chemistry class. And they definitely have a different take on Pogle compared to the freshmen. So I think they see the value of it much more than the freshmen do. Want me to just wrap up really quick?
Please.
Okay.
Two things.
Go ahead, Jake.
Two things. One, group dynamics research suggests actually four is better. Four is better in terms of combining people into groups. Secondly, the research I've seen on group dynamics suggests that they need to have both a short-term reward and a long-term reward. They need to understand that what's the short-term experience they're getting out of it, and also what's the long-term gain they're getting out of it.
Right.
To really be successful. So.
Okay. So just to wrap up really quickly, this is what we're doing in the future. So I'm definitely going to continue to work on my facilitation. We're starting this research study. Does a Pogle experience in first semester general chemistry affect retention of science majors? We've had colleagues at other institutions that have been tracking this and have found that students that had the Pogle experience in their initial semester showed increased graduation rates relative to those in a traditional chemistry class. And I also have an honors student that is working on a study to see if there's a correlation between a logic test, the GALT score, and the performance on a conceptual version of the ACS exam. And if there is the correlation affected by learning environment? So there are lots of things that we can do, lots of questions to ask, things to ponder with this type of pedagogy. So I would like to thank my colleagues Sarah Porter and Keith Ryder, and also the two students that helped me last year, Catherine Swanby-Shuford, she got married in May, and Ben Billadu, and you all for your attention and for your questions and your input. Thank you very much.
Melissa, on behalf of the Blackwell Committee, I'd like to say thank you very much for being our final Blackwell Monday Talk series speaker. I'll present you the certificate.
Thank you.
And I'd like to thank y'all for a wonderful semester participation, from films about how the classroom is represented in film to employing pedagogical methods in the classroom. I think we've had a diverse array of speakers, including mother rats and exercise and sexual predators and everything else. I'd like to particularly thank Dr. Poises and the School of Graduate Professional Studies. I'd like to thank fellow Blackwell Committee members, Brett Zymick and Rachel Matthews, Carolyn Vaughn for the organizing everything, and from my own heart, the pigs and blankets today. And again, y'all, for your participation and your time and your interest and your feedback. We will be doing this next semester, taking a hiatus for the rest of the semester so we can focus on our studies and our research and our classroom obligations. But be on the lookout for an email soliciting. We'll consider the submissions from the rest of the submissions from this semester. We'll also be asking for other people's thoughts and call for proposals as well. So be on the lookout when we resume our talks the second week of classes in the spring. But thank you very much.